Well, that's the one we will follow up to Bangkok.
The GIA field gemology department is something very unique. We started it 6 years ago, and so far no other laboratory have invested in such program. And then they will send us the sample in Bangkok. Currently we are based in Bangkok, the world capital of the ruby and sapphire trade. We have the sample from Mozambique coming this morning. Let's check a little bit inside.
Look, this is the nice stone we found at the washing plant in Montepuez.
Yeah, that's a good one, huh?
Our main objective with the field gemology department is to do research on color stone. With that research, origin determination is an important part because our customers are asking us where the stones are coming from. When the sample arrives in the lab, the first thing we are doing is we are checking if all the samples are here. Then all these samples will go to the librarian. The librarian will take high-resolution photographs of the sample, assign a barcode to every sample, and put them in the GIA reference database. So this is the first very important step. We need all the stone, all the sample to be documented. Then when there is a research project going on, I'm taking some sample out of the database, selecting them, and then these samples are going to the analyst. The analyst, the first job they will have to do will be the fabrication. The sample, when they arrive in the lab, when we get them in the field, they are rough. So the second step will be fabrication. Here mainly we are working with ruby and sapphire. There is something specific about that. It's for ruby and sapphire, the light doesn't travel at the same speed in all the directions. This is very different from single refractive stone like diamond, garnet or spinels. So the first thing we'll have to do regarding fabrication will be alignment of the sample because we will be able to study all the sample in the same direction. So for that we are using an alignment machine with a laser. We'll put the stone under immersion in order to find the optic axis. Then we will dop the stone, and this will enable the lapidary to polish two facets exactly perpendicular to the C-axis or parallel to the C-axis. Regarding the polishing of the sample, we have to take care of a few other things. Number one, we want the two facets to be perfectly parallel. We need no wedge. We will need the fabrication on the polish to be optical quality polish. Then after that, when the sample is completely fabricated, we are using a high-power microscope and we will be able to document the inclusion inside the sample. Then, using another instrument called Raman, we will be able to analyze and to identify the different inclusion inside the ruby, the sapphire or the emerald we are checking. We will also collect some spectra. Using infrared spectroscopy, we'll be able to get some information about the inclusion you have inside. You may have microscopic inclusion. You may have some interesting features that will appear when you check the infrared spectra. Then we are also using another spectroscopy instrument. It's UV visible. With UV visible, we'll be able to analyze the color, to understand where is the origin of the color for this sample. So we are collecting also this spectra, and we want to have high quality spectra. Finally, we will also work with the chemistry. We want to be able to study the sample at the trace element level. All this trace element will be very important if we want to get the kind of chemical fingerprint of the sample. And this will enable us to maybe separate a ruby from Burma with a ruby from Thailand or from Cambodia or from Mozambique. So the key thing to understand about what we are doing as a field gemology department is that this is really a teamwork. Teamwork between the people going to the field, the people cataloging the sample, the people collecting the data, the people fabricating the sample. And the main purpose of what we are doing is to provide good quality data to support our colleagues working on the stone that were submitted by our customers in all the different GIA labs worldwide. It is like a chain, and the strength of our research will be as strong as the weakest element. So we have to be very careful with every step of the process.